5.7 talks about solving trigonometric equations. It says a trigonometric equation is an equation that contains a trigonometric expression with the variables such as sine of x. Identities, remember, such as sine squared plus cosine squared equals 1 are true for every value of the variable, and solutions are the values that satisfy the equation. We'll begin by finding solutions for one revolution from 0 to 2 pi, and then we'll expand to find general solutions of these equations. So we've already done some of this. We did this back in the beginning of chapter 5 here. So I know the order isn't real great that they put these lessons in, but we're just going to have to deal with it. So some of this may look a little new, but like here we're going to talk about graphing it. We didn't graph it before. We just solved it algebraically. So I'm going to show you how it is on a graph, and then we'll be moving into algebra again. So it's not really anything too new for you. It's just refreshing you over it. Alright, so example 1. So let's solve by graphing sine of theta is equal to 1/2. Well, let's remember what sine of theta looks like. Well, sine of theta, same thing as sine of x, has a parent table. And so remember, your x's go from 0 to 2 pi. And sine is the one that starts at the origin, and then it goes up, comes back down, and then goes back to 0. So if I was going to graph this, just looking from 0 to 2 pi, it would look like this. Now remember though, this graph really keeps going, and we could go ahead and follow our pattern. Now remember, sine is odd, so it's not going to be a reflection across that y-axis, okay? So that y-axis does not split this graph in half. Now, if I want to look where it's equal to 1/2, well, where is 1/2 on our y's? Well, it is somewhere approximately right here. And so we can see that they are equal right there, looking at 0, between 0 and 2 pi, okay? Now, it's hard to really tell where those are at, but if you think about what you know on the unit circle, where is sine equal to 1/2? Well, sine is positive in quadrants 1 and quadrants 2. And so in quadrant 1, sine is your y value. Y is 1/2 at pi over 6, or 30 degrees, and at 5 pi over 6, which is 150 degrees. So we know that sine of theta is equal to 1/2 at pi over 6 and 5 pi over 6 when looking from 0 to 2 pi. Now, what if we weren't looking from 0 to 2 pi? Remember, this graph is going to repeat itself, or we can see over on the left there where we drew it. See, there's 2 more. Where would those spaces be? Or where would that be equal to? It's going to be where it is coterminal to pi over 6 and 5 pi over 6. Alright, so sine of theta equals 1/2 at all coterminal angles to pi over 6 and 5 pi over 6. And this is when we look at it from negative infinity to infinity, okay? So it has what we call infinite number of solutions. And this is where we talked about like that plus pi n k before. And so we'll be looking at that in a little bit.